Hello everyone. Today I will be showing you how to create a linked list and perform operations like deletion, insertion and displaying the current linked list. So to do that, first we will be needing a little instruction on a linked list. So a linked list is basically a linear data structure. So here in a linked list there is a component called node. So a node have two parts. There is one part is told the data, there is the data that user has entered, and the next part will be stores the address of the next node. That is this here, right here, will point toward the next node, that is the next node. This part stores the address of the next node, so this part will point toward the next node. That is the location where the next node is situated. So so to first we need to create a node in C. So to do that we have to implement it. So to do that I have written, what I have did is that I have created a structure of type node. Inside that I have defined a variable called data of integer data type. So that means the user can enter only integer types of data. And next I have created a pointer called next. So this pointer will point towards the address of the next node. So since this pointer can only point towards the address of next node of type node, so we have written data type it as struct node. So after this a structure for node will be created, and that is the custom data type of our own. So now the next part is the next part is the next part what we need to do is that we need to create a variable called start. So this start will at the beginning points toward null. That means a condition where no linked list is created and the pointer called start is pointing towards no node. Usually this star will point toward the beginning of the node, but since at first no node has been created, so we have to make sure that the start points toward null. So let's do that also. So to do that I have written struct node star start equals to null. So that means I have initialized the start variable as null. So next what we need to do is to create a node. So to create a node we have to use a function called malloc here. This function malloc. So what malloc does is that it creates a dynamic memory block for a particular variable of a fixed data, that is fixed size. So here malloc size of struct node. What this means is that malloc will create a memory block of size node. That is what the size of this node will be. It will be created by malloc. Here I have written struct node start because we have to typecast it so that it returns node type of address only. If here we written it as float, so this malloc will return address of memory block of type float. So we have to code it in the code blocks now. So to do that I will create a function called create node. A function called create node. Inside I will declare another variable of data type node, and I will name it as new node for simplicity. Now what we need to do is type new node equal to typecast it as of node data type, then followed by malloc function. Inside malloc write a predefined function called size of that will determine the complete size of the newly created data type called node. So this task has been done. So this task has been now done. So now what we need to do is ask the user to enter some data for this particular node. So let us write it enter the data. Scanf. We have to write this name. Oh, sorry, there here will be a star, since this is a pointer, so a pointer, only a pointer can point towards address of a the address of a memory block. So since this malloc is only returns the address of a memory block, so we have to store it in a variable that can store or point towards a address of a memory block location. So here, that's why here we have created new node as a type of pointer variable. So since we are going to access the data members of node, that is data through pointer, we will be needing to use an arrow operator instead of dot operator. So write new node arrow data. So through this, the user will enter a integer data, and this scanner function will store the data to structure data member data. Now we have to initialize the next part of this newly created node to null. So by this statement, what we mean is that we have created a memory block of data type node and name it as new node. So it contains two parts, that is data, and one part will store null. So we have stored this part as null because at first no linked list has been created, so only a single node has been created. So a single node, the end part of this single node will point toward null, so that's why we have written here null, and the data will be entered by the user. So after this, two case arises. Case one, first case is that we have created in a new node, only one node, that is we have created only one node. So if we have created only one node, then we need the start to point toward this newly created node here, and this next part will be point toward null. So now we have to code start to point toward this node. So to do that, let us open code blocks again. Now case one, I will write it here. If start equals to null, that means start is pointing toward nothing. We have to make the start to point toward the newly created node. So start equal to new node. So through this code, start will now point towards the newly created node now. So after this, there are another case 2. If there is already a created linked list, so we here in this part, we have what we have done is that we have created new node from the user. Now we want this new node to insert on the beginning of this new already created node. So to do that, in this already created node, the start will point toward the beginning of the node. So now what we want is that this start to point towards this newly created node, and the next part of this node to point towards the previous created node beginning. So to do that, what we need to do is that start will point toward this node, we need to create another variable called temp. So this temp will also point towards the previous head of the node, that is the previous beginning of the node or start of the node. Now after this, we need to assign this start to point towards the newly created node, and the next part of the new node to point towards the beginning of the previously created node. So to do that, let us write else part. So we will create a new variable called temp and assign this temp as equal to start. So at the beginning start and 10 will point toward the same location, that is the same node. Now this start variable, we need this start variable to point towards the newly created node, that is new node. So we will write new node now. New node. Now in this diagram we have successfully pointed the start variable to point toward the new node. After this, what we need to do is that the next part of this node should point towards the previous head of the node, the address of the previous head to the node. So at the beginning we have used temp to point toward this node, and this node is itself the head node. So this next part should point towards the temp now. So new node, next part will now point towards the temp. Now it's done. By the, through this code we have made a new node, and this new node have been inserted in the beginning, and the newly created have now 3 nodes. This is 1, 2, 3 nodes, and this start is pointing towards this newly created node, and this is pointing towards the previous head of the node. That is, now this is a complete linear linked list. So this part has been done. So now let us create another function to delete the node. Here in this code also I will create this function delete node to delete the data, that is the node from the beginning. So again we need to make a temporary variable so that to store the previous data of the currently pointing start, and again we have to write temp equal to start. So by this part what we need to do is that there is so what we need to do is this node to be deleted. We need this node to be deleted, and if this node has been deleted, then the start should point towards the next node. It is node number 2. This will be node number 1, and this will node number 2. So to do this, now start should point toward the next node, that is this node. So to do this we have to write start equal to start next. By this then what meaning that the new start next, that is this part, start next is this. So this will not, this is always point towards the next node. So what we have did is that the new start will be equal to the start of next, that is this next will point toward this. So start will now point towards this new second node. Now after this, since temp is also pointing toward the first node, temp is also pointing towards the first node. Now start has been pointed towards this second node, so we don't need this node anymore. So we have to disallocate the memory of this node part. So to do that, there is a predefined function in C called free. So what it does is that it disallocate a particular type of it disallocate the memory of a particular variable. So here temp is pointing toward this, so we need to delete this node. So to delete this, we have to write temp inside free, so that free will disallocate memory for the temp, that is this part. After this has been done, so now what this part will do is that it will delete the first node from the linked list. Now but there's also one condition here, that if the node has not been created, that is if start equal to none, by this it means that the node has been not created. So if we write this, then we have to print that the node is empty, deletion as an how can we delete a empty node? So if the node is empty, then deletion is not possible, so that's why we have written here. Now this will be on the else part. So function for delete node is also created now, guys. Now we have to create another function called display that will display the current node. Here again, to do this, let us define a node type of variable stem again for it to display. So for backing up the start pointers, we have to assign it again as temp equal to start. So by this we have to traverse now. This process is called traversing. I will show you through diagram. Here will be the start. Start. So now what we have done is that we have created a variable called temp and made it points toward the beginning of the node, that is temp equal to start. So now what we need to do is that traverse this linked list until there is null is not found. So to do this, first we have to write this code. We will use while loop here, as we don't know how long the linked list is. So now temp is not equals to null. At first temp is pointing toward the beginning of the node, so we need temp to point toward the next node on the first iteration. We need temp to point toward the next node on the first iteration. So to do this, we have to write a code called code again. Temp will now point towards the temp itself, next of the temp itself. So on the first iteration, temp is pointing toward the first node, that is this node. After second, now the temp will store the address of the next node, that is this node. So after the second run, this temp will store the address point towards this node. and after another third run, this stem will again point toward this node, and this stem will now at last this stem is now will point towards null, so this loop will be stopped. But so now we have to show the data of each part, this part, this part, this part. So we will write a print statement. Partially temp data. So each time this loop learn the data part of the linked list will be displayed on the screen through this code. Here also there is a condition. If at the beginning the linked list is not being created, then displaying is not possible again as of in the deletion part. So we will print again a message that displaying is not possible. Now, and if the linked list is present, then run this code, else part. So here guys, we have successfully created three functions, that is display, delete node, and create node. So now to implement this, I have already created some code to implement this, so I will just copy paste this code into the main folder of this one. So here what I have done is that I have used switch case statement to create a menu driven program. So option 1 will ask the user to ins insert at the beginning. 2 will be option for deletion at the beginning. 3 will display the current linked list. 4 will for exit, and we have to enter our choice, and the scanf will input the choice and store it on the choice variable, and switch case will be now run. Case 1, the create node will be created, then break statement cause as we don't want fall true condition to occur. Case 2, we call the lead node, and so on. And case 4 will exit the program and default wrong choice, enter once again. If the specified 1 2 3 4 option has not been entered, another option has been entered, then this message will be printed. But here we see that exit is written, so the program will not work if there is not a header file included here. Another header file, this header file is called std lib. This header file stores the function called exit, this function exit here. Now the program has been created now, so let us try and run it. As you can see, the program has been successfully run with no errors. So here what displays insert at the beginning, deletion at the beginning, display the current linked list, and exit. So first let us check the those conditions, that is if no linked list has been created. So let us first check the deletion at the beginning part. It should print that the linked list has not been created, so the list empty deletion is not possible because since we have not created any linked list yet. So let us now type 3. Displaying is not possible because again we didn't created any linked list yet, so displaying is also not possible. So now let us call the first part, enter the data. Let us enter the data as 45. Now this has been done, so we have successfully created a one node which stores data 45. So now let us try to print it. As you can see, the current list is 45, that is pointing toward null. That means only one node has been created. So now again let us create another node that will be on the beginning of 45. 45 should be the next node now. So let us create another node of data 23. So it has been done, so let us display it. As you can see, 23 is now pointing toward 45 and 45 next is pointing toward null. 23 has been inserted at the beginning of the 45. Now let us perform deletion. So if I press 2, select 2 and press enter here, this 23 will be now gone. So this program has been executed. Now display the current linked list again. As you can see, 23 has been now gone. 45, there is only one node 45 and the next part is pointing toward null. So through this program we have successfully created a linked list of 3 operations, that is insertion at the beginning, deletion at the beginning, and display the current list. Now let us exit the program. I have enter 4 and it will exit the program, and press enter again, it will exit the entire program. So I hope you guys like this tutorial. So if you like it, be sure to subscribe, like and share the video, and if you have any doubts regarding this video, be sure to comment down below. So I hope you enjoyed it guys.